Question number 13. We have 6 parts. It says a projectile is fired vertically upward, has a position function given by S of t here, and that is from 0 to 7, and we're going to complete parts A through E. So first we want to graph the function, and it gives us a viewing window. So again, I'm going to grab our calculator. I'm going to go to y equal. I'm going to clear out what we have, and I'm going to enter this equation. So negative 16, it says t squared, but our calculator inputs the variable x. So we'll be using x. I'm going to add 96x, and then we're going to add 112. All right, we're going to graph this function. Now the standard viewing window is negative 10 by 10, but we want to change it to these parameters. So I'm going to go to window. We're going to tell it to start at negative 4 in the x direction. We're going to go up to 7 in the positive. We want to count by ones, so that's the scale. Then as far as y values go, we're going to start at 0. We're going to go up to a max of 900. And we want this to count by 100s because that's a bigger gap. So we're going to count by 100. And now we're going to see the new image. Okay, so we get this parabola shape. The one that looks best would be here. Now we can also restrict our graph. You see how it says from 0 to 7. So that means we're not going to be considering any negative values, which we cannot start at a negative time because t is the position and we can't have a negative position. So if you wanted to see that cut off, so you can restrict the graph, I would need to put my function in parentheses. So I'm going to do second and insert, and I'm going to open parentheses right here. I'm going to go all the way to the end, and I'm going to close parentheses. So when we do restriction, we have to do divided by. So I'm telling the function divided by, and then I have to do it one piece at a time. I can't do I don't think the calculator inputs what we call this a combined or a conjoined inequality. We have to do it one piece at a time. So I'm going to do t with 0 and then t with 7, in this case x. So I'm going to open up parentheses. I'm going to say 0, and then we have to do test. Those will give us our inequality symbols. So if I do second test, I get my inequality symbols, and we're going to do less than or equal to, which looks like option number 6. And then we're going to say x. So I got that part, and then I have to do second test again, and I'm going to go over to logic. We got to say and, because we have 2 parts. So I got to do 0 less than or equal to x, and we're going to say x is less than or equal to 7. So I'm going to say x, second test again, and we're going to go option number 6, and then we're going to say 7. Okay, and then close parentheses. So this is going to restrict our graph. So if I hit graph now, it cuts off that little tail and only goes to 7. So you don't have to do that, but if you like to, that's how that works. All right, so it says from the graph, the position function, we're going to identify the time at which the projectile has an instantaneous velocity of 0. We're going to call this time TA. So instantaneous velocity of 0 means the slope of this is 0. That's going to be this horizontal line here, which is the maximum. Looks like that happens at 1, 2, 3, and we go up maybe to 200. We cannot see that all the way, but let's just do this. We're going to hit trace. I'm going to input 3 and get that maximum value of 256. So this is just estimating, but we can do a maximum as well if we wanted to confirm that. So if I wanted to find the maximum point, I can just do calculate. So I'm going to do second trace to calculate. We want to find the maximum, so number 4, And then what your graph wants to input is it wants you to trap the place where you're looking for the maximum. So you want to go to the left of it, anywhere to the left, hit enter, and then you're going to go to the right of it. So I'm looking at the y values increasing, and then when they start decreasing, I'm going to hit enter. So I know that I have the maximum trapped somewhere in here, and it's going to ask you to guess. You just hit enter again, and it computes. And so what it says is 2.99999, which roughly is 3, and we get that 256. So we're going to say when the x value equals 3, that's where we're getting that maximum value. And now we're going to do a table to compute the secant lines. So again, I'm going to let the calculator do all the heavy lifting. I'm going to go to stat, I'm going to go enter, and again I'm going to clear out. So once we had the data from the previous problems, just arrow to the top and hit clear, arrow down, and it will just clear everything. Clear, and we're going to clear. Okay, so this time my starting value is 3. So we're going to be inching closer to 3, and then be dropping down from 3. So I'm going to put 3 5 times, 2, 3, 4, 5, and then we're going to be inching closer to 3 from 3.5. Sorry, I didn't get that out of the way. 3.5. That's going to be 35. Okay, let's make sure to get this 3.5. There we go. 3.5. It's not wanting to pick up. 3.5. There we go. 3.1. 3.01. 3.001. And 3.0001. Okay. I'm going to go over, and we're going to compute the y value, so the numerator of our slope formula. So I'm doing this again, but we're using our functions, and we're using L1 and L2 as our variable. So from here, I'm going to open parentheses. You got to have the top. Remember, you got to have your cursor on the top of that list. Negative 16. This is going to be L2 squared plus 96 times L2, and then plus 112, and then we're going to subtract, same thing but L1, so negative 16, this will be L1 squared plus 96 L1 for our x value, and then plus 112. So this is going to compute the y coordinate, the numerator, and then in L4 I'm going to have it complete the overall slope. So I want it to grab the L3 column, that's my y value, and we're going to divide by the difference. So that is going to be L2 minus L1. Alright, so we get these values. I'm going to just slowly input them. So we get a negative 8. Then we get negative 1.6. And then we get negative 0.16. Negative 0.016, and then negative 0.0016. And then we want to know what is this approaching. We're going to round to the nearest integer, and that should be approaching 0.